In this video, we're going to review some of the big highlights of what we just accomplished inside of our project. I first want to discuss some of the differences between the remix editor that we were just using and writing our contract in our code editor. When we first wrote out our inbox contract over here, the remix editor seemed like a great place to author an Ethereum contract. We were able to get some auto completion when we wrote code in here. We could then immediately test the contract, and it just seemed like it was a really handy place to develop the contract. So why exactly did we decide to write the inbox contract over here in the code editor? Well, in reality, in a real project where you start using Ethereum, it usually ends up being the case that you write the contract rather quickly, and then you spend a tremendous amount of time working on the front-end application that is meant to interact with that contract. So as nice as Remix is, usually we might end up using Remix at the very start of a project to kind of work with and tweak a contract. But then eventually we end up inside of our code editor because the vast majority of work that we usually have to do is around writing tests for the contract and writing the front-end application. In addition, as nice as Remix is, it doesn't have built-in support for Git or GitHub or Bitbucket or any type of version control. And so if you expect to be working on a project with many other people, well, chances are you're going to want to use some type of version control so you can easily share the source code of your contract. And again, that's going to happen easiest when you're writing your contract inside of a code editor. After we installed our code editor, or after we got our project running inside of here, we then started working on our compile script. So here's our compile.js file. Inside of compile.js, we used the Solidity compiler. We then read in the contents of our inbox contract and fed that directly into the compiler right here. Recall that the compiler is really built for compiling multiple contracts or multiple files at the same time. So the output that we got back from this compile operation had a couple of different contracts associated with it, or at least the ability to read in multiple contracts. In this case, we only cared about our inbox contract, which is why we returned from this file :inbox right here. In case you're curious why we have :inbox, what is the colon doing here? Well, if we had multiple files, each of which contained different contracts, in front of the colon would be the file name that the contract source came from. So for example, if we just fed in, rather than the raw text of our contract right here, if we fed in a path to a couple of different files, and maybe our inbox contract was in a file called like inbox contract, then we would have had to access inbox contract right here. So again, this would usually be used to specify the file name. But in this case, we only fed in the direct source code, so we didn't have to worry about that. After finishing up our compilation script, we then started working on some tests. Inside the test file, we had a lot of different stuff going on. And so I just want to remind you about the purpose of some of these different libraries that we used. First off, we made use of Web3. This is our portal to the Ethereum world. It's how we retrieve information from the network, and it's how we make changes to the network as well. The Web3 library always has to be given a provider. The provider instructs Web3 what network it is connecting to, and it also contains some information about the different accounts that are available to Web3. In this case, our provider was given to us by the Ganache CLI module. Ganache hosts a local test network. So just like we had a tiny, very small network running inside of the browser with Remix, Ganache is doing the same thing. So Ganache automatically generates some number of accounts. We can send transactions to this network. We can deploy contracts to this network. It really is a tiny little test network. The important thing to remember about Ganache is that it always automatically completes or processes transactions almost instantaneously. And that's why we like to use Ganache inside of any test-related code like we did right here, because we want our tests to run as fast as possible in general. Inside this test file, we also imported two important things from our compile file, both the interface and bytecode. Remember that the interface right here is our ABI. It is the translation layer that communicates data from the network over to the JavaScript world. And the bytecode was our compiled contract. We then used Mocha to set up a testing harness. We defined a before each function that automatically got a list of all of our available accounts, and then deployed a new instance of our contract to the Ganache local network. The important thing to keep in mind about this before each right here is that it is executed before every one of our tests. And that's really important. We want to make sure that as we start writing tests, we are always working with a fresh copy of our contract. If we write a test where we start to modify a contract or even delete a contract, then we want to make sure that those changes don't boil over to the next test that gets executed. We always want to be working with a fresh one. Inside of our describe block right here, we provided a couple of different it statements, each of which was meant to test a different aspect of the contract. Inside of each it statement, we were able to access the contract directly and then get access to some of the different functions that belong to that contract by accessing this methods object right here. Remember that the methods object contains all the different functions that belong to the contract. So in our case, we had a message function and a set message function, and we were able to get access to both those from the methods object. The other thing that was kind of awkward about this methods object is that whenever we accessed a function on it, we had to do kind of like two sets of calls. We had to first reference the function we wanted to call, and in this first set of parentheses, we provide any arguments that need to go directly to the function in the contract. After that, we then specified either call or send. Call is used anytime that we want to call a function. And remember, calling a function is a read-only instantaneous operation. When we send, that means we want to make a change to the data that exists inside of our contract. When we send, it is not an instantaneous operation, and we have to wait a pretty significant amount of time for a send operation to be completed. We also have to specify exactly who is going to pay for that transaction as well. Now, of course, on our local Ganache network, any send operation gets processed instantly. So we didn't actually have to wait very long for it to be completed, but in theory, in the real world, we would have to wait anywhere from, say, 15 to 30 seconds or so. So that was our testing file. Now, the last thing I want to go over, and I know we just wrote this, so it might seem like premature review, but hey, what the heck, let's go over it. Our deploy script here. The second half of the deploy script looked very similar to what we just went over inside of our test file. So we used Web3 to get a list of our accounts and then deployed our contract. However, it's what went on the first half of this file that was really interesting. We used a module called HD Wallet Provider. The purpose of this module right here is to both connect to some target network and unlock an account for use on that network. In this case, we unlocked account by using our 12-word account mnemonic right here. By providing just this mnemonic, we are able to unlock and generate the public key, private key, and address of our account. We specified that our provider should connect to an Infura node. Remember, anytime that we want to connect to a real network and not one that is just hosted locally on our machine, we have to connect to a real node. You'll see a lot of documentation out there that advises you to use modules like, say, geth or parity on your local machine to connect to the Ethereum network. However, setting those modules up is a real pain in the rear. So wherever possible, I really recommend making use of Infura because it is a free service that is rather easy and straightforward to use and doesn't require you to host really expensive nodes on your local machine. After setting up this provider, we then fed that provider to our Web3 instance, and then we had a copy of Web3 right here that was pre-configured to connect to the Rinkeby network and had already unlocked one of our accounts, which had some ether and could be used to deploy our contract. Ooh, all right, so that's a lot of knowledge. We went over a lot of stuff, but I can guarantee you one thing, we are not done yet. So we still have a tremendous amount to learn about Ethereum. We're gonna pause here. We're gonna start working on our next project in the next video. So I'll see you over there.